Hi, everyone. Welcome to our webinar today. Today's webinar is presented by the Energy Storage Technology Advancement Partnership, also known as ESTAP. ESTAP is a collaborative of the Clean Energy States Alliance, Sandia National Laboratories, and the U.S. Department of Energy Office of Electricity. The topic for today's webinar is SMUD's carbon reduction strategies, smart homes, strategic electrification, and energy storage. We have an excellent guest speaker with us today from the Sacramento Municipal Utility District, also known as SMUD. And before we get to that, I would like to go over some quick housekeeping notes. All of our attendees are in listen-only mode. You have a couple of options to join the audio portion of today's webinar. You can call in using a computer, mic, and speakers, or you can use your telephone to connect. If you'd like to minimize the webinar console so that you can view the presentation full screen, you can use the little orange arrow that you see circled there, and that arrow will also expand your control panel so that you can see that once again. We encourage you to submit your questions and your comments throughout the webinar by typing them into the questions box on the webinar console and hitting send. We will be reading through your questions and comments throughout the webinar, and we'll get to as many as we can at the end. We're going to save about 15 minutes for a Q&A with the audience. We do expect a lot of questions, so to make sure that we get to yours, type it in when you think of it. Don't wait until the very end. A final note, this webinar is being recorded. We will send you an email with a copy of the webinar recording within about 24 to 48 hours. And we will also be posting the webinar materials, both a PDF of the slides and the video recording, on our website at cesa.org/webinars. So with that, I would like to pass you over to our host for today's webinar, Val Story. Val is a project director here at the Clean Energy States Alliance. Val?
Thanks, Sam. Hi, everyone. This is Val from CESA. As many of you know, CESA is a national nonprofit organization. We're based in Montpelier, Vermont, and we work together with our state members to advance clean energy technologies, and we do that by supporting innovative and effective state policies and programs. We facilitate, in addition, information sharing among our state members, whom you can see on the slide that was just up. Sam can pull it back up. And those are all our state members. And we also coordinate multi-state projects, and we provide policy and technical assistance. An example of policy and technical assistance that we provide is the ESTAP project. The ESTAP project, as Sam mentioned, is the Energy Storage and Technology Advancement Partnership. It's a project supported by the U.S. Department of Energy and Sandia National Labs, and it is managed by CESA. And together, the partnership provides technical, policy, and programmatic assistance on energy storage initiatives across the country. And you can see some of the ESTAP projects on the map on the right of the screen, on the right of the slide. And through the ESTAP project, CESA also shares information with stakeholders and facilitates public and private partnerships to support joint federal and state energy storage demonstration projects. We also host webinars, and this webinar is a webinar with SMUD, the Sacramento Municipal Utility District. In the past, we've held webinars on ESTAP projects with municipal utilities as well as with investor-owned utilities. And on this webinar, we're branching out beyond the ESTAP-supported utility projects to look at how energy storage projects and technologies are being developed and deployed in other regions. And so today we have invited Rachel Huang. She's the Director of Energy Strategy, Research and Development at SMUD, and she'll be talking about several of the utilities programs that are incentivizing and deploying energy storage technologies. And as Rachel will mention, in 2018, SMUD adopted a net zero carbon target for 2040, and to reach this significant goal, they have many projects including a home electrification program. That's a significant strategy for meeting this goal. And so Rachel will be talking about SMUD's Smart Homes program for new construction that incentivizes solar, storage, electric vehicles, heat pumps, and other technologies. And she'll also be talking about SMUD's approach to designing storage solutions, including a new residential program for battery storage, over which SMUD controls over 51% of the batteries dispatch. And then she will also talk about how SMUD dispatches the storage and the benefits to the utility and to the grid and to SMUD's customers. So that's just a brief overview of the presentation that Rachel has prepared for you. Let me introduce Rachel. As I mentioned, she's the Director of Energy Strategy, Research and Development at SMUD. Her responsibilities include the development of the strategic roadmap for distributed energy resources, the research and demonstration of innovative and emerging technologies, and the coordination of their execution across the enterprise. She holds a BS in chemical engineering from Cornell University, and she did graduate work in energy and environmental policy at Johns Hopkins School of Advanced International Studies. Rachel, thanks for being with us. I'm going to pass it over to you now.
Okay, great. Thank you, Val, and thank you to ESTAP and CESA for inviting me to speak today. So first, I'd like to dive in a little bit about SMUD. So we are a community-owned and not-for-profit publicly owned utility. We're the 6th largest community-owned utility in the United States. We are governed by our own 7-member elected board of directors that are elected by our ratepayers. We're not part of a local jurisdiction, so the board is just governing us as an organization. We have a little over 600,000 customers and a little over 2,000 employees, and our budget was over $1.7 billion this year. Just for some perspective, our record peak demand was 3,300 megawatts set back in July of 2006. We actually haven't hit it since back then, which really speaks to the effectiveness of energy efficiency and the growth of distributed energy generation within our service territory. And then just for perspective, if you factor in the large hydro within our service, within our power mix, nearly 55% of SMUD's power mix is already carbon-free. So as Val mentioned, we actually set a new goal with regards to our integrated resources plan and our greenhouse gas reduction a little bit over a year ago. So in October of 2018, our SMUD board approved a new greenhouse gas goal target for net zero carbon emissions by 2040. What's significant about this is that the $6.7 billion investment that we'll be making over the next 20 years, of that, we expect that $1.7 billion of that will be invested in electrification measures. This was a deliberate choice by our board of directors in that we could have actually done our IRP and met this goal with investing in more large-scale renewables. However, as a publicly owned utility, especially one that is in an air attainment district, we wanted to make sure that we had emissions reductions within our service territory locally as well. And so that $1.7 billion of investment in electrification, both into building electrification as well as transportation electrification, will be helping us reduce our greenhouse gas emissions. I will caveat this with that the regulatory framework does not currently allow us as a utility to count the fuel switching towards our own emissions reduction, but that's something that we've been working on with our local regulatory agencies moving forward. For perspective, we expect that in 2040, our own carbon emissions footprint will be about 1 million metric tons, where about 70% of that 1 million metric tons will be reduced by our efforts in transportation electrification, and the balance of the 30% will be from building electrification. Oops, sorry. This chart gives you an idea. So as Val mentioned in the intro, I'm the director that oversees our distributed energy strategy at SMUD. And that was actually a group that was formed back in 2015 with recognition that the electric industry and the energy industry was moving towards a more distributed future. Interestingly, we actually were moved from the customer side of the business into the grid Grid Planning and Operations Group, because there was recognition that these distributed energy resources were not only valuable for our customers, but could provide significant value in the grid. When we developed our first distributed energy strategy back in 2016, we did have building electrification as one of the key components of our energy efficiency strategy back in 2016. However, with the aggressive goals that we've now set with our integrated resources plan, you can see sort of the pre-IRP 2018 forecast versus our new integrated resources plan goal, that our new integrated resources plan goal are requiring us to make significantly more investments to drive adoption within building electrification. For some perspective, in 2019, we expect that we'll have about 1,000 homes electrified by the end of 2019. And by 2030, we'll need to do 20 times that and be up to 20,000 homes electrified by 2030 in order to stay aligned to our new integrated resource plan goals. So as Val mentioned, I'm going to talk a little bit our Smart Homes Residential New Construction Program. For perspective, new construction within our service territory is about 2,000 to 4,000 homes per year. The strategy that we developed behind our program was to provide incentive packages that accelerate market transition from mixed fuel to all-electric homes while increasing overall customer and builder choice to ensure that smooth transition. So to do this, the SMUD Smart Home Program established a minimum set of criteria that builders have to meet in order to be eligible for the incentive. And from that point, the program provides a list of incremental additions the builder can sign up for to increase the overall per home incentive. As you can see, there's actually 4 different options with regards to our residential new construction program, and it has options for mixed fuel, so those that are going to have both gas and electric, as well as all electric homes. In California, our building code Title 24 does require, starting next year in 2020, that all residential new construction requires solar. So we've got options for both on-roof solar as well as our neighborhood solar shares program, which is SMUD's community solar program. We do have incentives for battery storage, which I'll talk in more detail in a little bit. But we are requiring for all of our residential new construction pre-wiring for all electric, as well as pre-wiring for EVs. So talking about mixed fuel homes being pre-wired for all electric conversion, at SMUD, we put a lot of thought into retrofitting existing homes to be all electric. The most affordable time to go all electric is when a home is being built. And even though not all homes will be electric, we can still take advantage of this lowest cost window to make electrification as simple as possible when the conversion does eventually occur. In terms of pre-wiring for EV charging, there's 2 considerations that we looked at for this element of requirements for our new construction program. First is that most homes built today do not actually provide wiring for an EVSE. They just provide space in the electric panel for a breaker and route for the wire to be run into the garage. This leaves a meaningful barrier in place for someone considering purchasing an electric vehicle. And so therefore, by requiring the breaker installation and the full wiring of an outlet in the garage, customers can be more confident that if they purchase an EV, they can easily charge it at home. Furthermore, when we look at EV charging, we mainly think about 1.2 kW for level 1 charging or 6.6 kW for level 2 charging. However, the newer generations of EVs are able to support much higher charging rates. So for example, Tesla actually has a charging option at the residential scale for as high as 19 kW. Considering the fact that EVs are normally about 1/2 to 1/3 of a residential home's load, that level of EV load creates significant risk of infrastructure overloading and could result in increased grid infrastructure costs. And so therefore, by including the full pre-wiring of the EVSE in the home design at the 6.6 kW, we're actually lowering the bar to EV adoption and home charging, but we're also not encouraging the use of very high-powered EVSEs for residential applications. Of course, customers can upscale if they need to, but at least this gives the baseline for customers to just go ahead and plug and play. As you'll see on the far side of the table, we actually had some requirements as we thought about it for transformer spacing. So new construction's been really become very space efficient, especially in California. Lot lines for homes are really close together, and clearances from the street are often designed to minimize wasted space. The space efficiency puts pressure on our infrastructure design team to serve more homes from fewer transformers, or else that we have to upsize transformers during the design phase. Historically, SMUD's been able to accommodate a number of these requests, but as we look ahead to a future with EVs replacing combustion vehicles and the electrification of homes in general, the load considerations of local infrastructure has shifted. So sizing the transformer to the number of homes that it serves, where our standard is a 50 kVA transformer for every 10 homes, it gives us the flexibility to electrify communities in the most cost-effective way possible, where DERs can help support the standard design and room to upgrade the transformer if needed. In general, if we need to scale up, going up from 50 kVA to 75 kVA is easy, but once we start going much above 75 kVA, it starts to become challenging, and supporting transformers larger than 100 kVA often brings up other infrastructure challenges such as voltage as the first and last home. And then finally, in addition to the home attributes, the SMUD program also provides longer-term contracts for builders that are moving forward with all electric. So for builders that are willing to go all electric from the beginning, SMUD's willing to contract incentives up for 5 years, which is pretty significant. When you think about when a builder makes a commitment for a community, they have a plan of how quickly they're going to build out the home, but depending upon how the demand is, as well as one of the things that Sacramento experienced and California experienced in that 2007-ish time frame for a couple years was the real estate crash. And so while SMUD had contracted for certain incentive levels for PV, for example, at the time, a lot of those expired before all the homes were built out. So this gives a little bit of risk mitigation to our builders as well. With our residential new construction program that we launched, it's actually catching on. We're actually seeing a lot of interest from developers within our service territory. In 2019, we just launched this program in 2018, and by the end of the year, we expect to be over 3,000 residential new homes under contract. We're also seeing a lot of interest statewide with regards to municipalities adopting either banning natural gas or adopting building ordinances to require new construction to be all electric. In Sacramento, our city of Sacramento as well as West Sacramento mayors formed what they're calling the Mayor's Climate Commission on Climate Change. They have a technical advisory committee on the built environment, and the recommendation from that technical advisory committee was to mandate all electric construction to eliminate fossil fuel usage in new buildings by 2023. That was unanimously accepted by the Mayor's Climate Commission, and we expect that to be adopted by local jurisdictions either by the end of the year or early next year. This slide actually shows you the process that we developed as we think about market transformation for going to all electric, with our vision to transition all new construction to be all electric. The savings are maximized when the builder is able to avoid all the costs associated with installing gas infrastructure, but at the same time, we realize that from a market demand standpoint, induction cooking, for example, is not necessarily widely adopted, or customers aren't necessarily very familiar with that, and that's a selling point that I know some developers still have some anxiety about. When we initially launched our residential new construction smart home offering in 2018, our only option that we gave was all electric. There was no transitional product, and while the program was effective at engaging developers that were in the planning stage, we actually found that a number of builders that were not in a position to engage with SMUD on an all-electric project because they had already installed the primary gas infrastructure or had even built out a significant portion of a community as mixed fuel. So there really wasn't an option for a mixed fuel incentive where at least some of the technology within the homes could be electrified. These builders didn't have a clear engagement path with SMUD, which meant that mixed fuel homes that were built weren't going to be all electric ready, and they wouldn't have pre-wired EV charging, which could also create infrastructure challenges for the future when electrification does occur. So in 2019, we updated our residential new construction program with an on-ramp to allow SMUDs to engage with builders at every phase of the development process. So even if builders have not come to us until they're a little bit further down the road, our program allows an option for a mixed fuel transition for nearly all participating builders to participate. And actually, interestingly, nearly all participating builders that have signed up for the all-electric alternative to the program. So we've developed this on-ramp for those that either are, like I said, concerned about the induction cooking piece, but we are actually seeing a lot of uptake of all-electric, which is really aligned to our strategy of eventually, as you can see with the red arrow, eventually eliminating those transitional products over time, but recognizing that we need it now. And as you can see, based upon the flow diagram, there's options for those that cap electric at the curb, so at the home, as well as those that are all electric ready. And when we talk about all electric ready, we talk about wiring that actually goes to those end uses that are even plumbed as gas today, so that in the future, whether it's based upon codes or if just in general the customer is interested in all electric, that they're able to just go ahead and plug and play with regards to those appliances and technologies. And for a residential new construction program, as I mentioned, we're at nearly 3,000 homes under contract today. So battery storage. Oops, sorry, I clicked ahead a little too quickly. Battery storage. What does battery storage look like for a residential new construction program? So under Title 24, as I mentioned, starting in 2020, PV is required for all new homes, but also as part of Title 24, batteries are actually now included as a compliance tool. Now, the way Title 24 is currently written is that the builders actually can choose how to use the design credits. So they can actually choose to use lower grade insulation or reduce other energy efficiency upgrades that would have otherwise been required if they put in battery storage. The alternative is that the PV system can actually be downsized so that less energy is sent back to the grid, or curtailed in some cases, during the midday when no one's home and renewable energy can be shifted to SMUD's on-peak period to address evening picking issues. So for SMUD's residential new construction program, our battery incentive for new construction actually requires builders to utilize the credits from the battery system to downsize the PV array. This requirement actually encourages the self-consumption of renewable energy. It still maintains a high level of energy efficiency upgrades in the home, which we believe is critical for residential new construction, while connecting the battery storage system to the grid that can support the grid through upcoming energy storage programs, which I'll be talking about very shortly. So what's been SMUD's approach with regards to battery energy storage? So in California, we have Assembly Bill 2514, which required all utilities to set procurement targets for energy storage. So the last time we set our AB 2514 goals was back in 2017. Utilities are required to set new goals every 3 years. So we'll be going back to our board and then filing with the California Energy Commission again next year with updated goals. But based upon our 2014 goals, we set a 9 megawatt target for 2020 and a 75 megawatt target by 2026. What this slide shows you is that it shows you the phases through which we are taking as we thoughtfully think about how we are going to be adopting battery energy storage in a way that provides the most value to both the customer and the grid. One thing that's a departure from the approach that the investor-owned utilities took was the investor-owned utilities within California took their AB 2514 targets focused a lot on utility scale storage, knowing that we could learn from their experiences from a secondary research standpoint. We actually chose, at least in this first year from 2017 to 2020, to really look at customer-sited and behind-the-meter battery storage business models. And so based upon the analysis within our service territory and where our trajectory of rates are going, in SMUD's service territory, we believe that cost effectiveness for storage is going to occur around the 2023 timeframe. So therefore, we're really focusing that first 2017 to 2023 timeframe to look at doing research demonstrations, testing out different business models, and understanding customer pilots that we can then scale once we get to cost effectiveness within our service territory. I'll be talking a little bit in more detail about the things that are listed here that we have been working on in 2017 to 2020. Our Smart Energy Optimizer pilot, where we're actually allowing, as Val mentioned, 51% control for the utility. We're also looking at data and aggregator integration, as well as access to locational benefits. In the next three-year tranche from 2021 to 2023, we're really going to be looking at business and integration optimization. So as we learn from those pilots in the first 3 years, how do we take those learnings to enhance program designs to maximize the shared value between the utility and the customer? SMUD is actually in partnership with OSI in developing a distributed energy resources management system. So we are using those pilots to help inform us in that co-development of our DERMS, as well as looking at integrating these different technologies into our DERMS for control, as well as looking at contracted behind-the-meter battery capacity. Moving forward, once we get to cost effectiveness, that's really where we're going to be looking at scaling those pilots based upon the learnings, looking at how we can access full value stacking for battery storage, and then deploying battery storage to meet grid needs. This slide talks about how we think about utility dispatch storage resources relative to those behind-the-meter storage systems. If you look in the lower right-hand corner with regards to the blue circle and the blue table, our integrated resources plan expects that we'll have about 246 megawatts of utility dispatch storage resources in 2030 and 560 megawatts of utility dispatch storage resources in 2040. What this diagram really shows you is that we don't believe that utility dispatch and behind-the-meter storage are mutually exclusive, that some of it will be utility scale, however, that we are really going to be able to leverage both residential behind-the-meter storage systems as well as commercial behind-the-meter storage systems. That way, and that's the reason why we're testing out these different business models in these early years before it becomes economic, so that we can be prepared, but also be able to leverage that co-investment that customers are making with being able to get utility value from those battery storage systems. So why do utilities need some control of the battery storage? This diagram actually shows you, and if you look at the lower right-hand corner of the graph, we currently have time of day rates for our residential customers and time of use rates for our commercial customers. They're obviously built based upon customer class, so they don't get to the granularity of things like locational grid values, and pieces like that, especially with the balance of simplicity that we need to make sure that we have as we design rates that customers can understand. But currently, based upon SMUD's rates, if you look at a customer that would just dispatch their battery based upon SMUD's current residential time of day rates alone, customers get about $68 to $69 of value. However, for the utility, that value is actually negative, and we're actually losing revenue if customers are dispatching their batteries based upon the time of day signal. However, if we look at direct utility dispatch, we can still provide $62 to $63 worth of value to the customer, but actually change that value proposition to the utility to become a positive one. So really this speaks to how do we think about being able to develop that ability to control the battery storage and test out what are those models to be able to get that shared value for both the grid as well as the customer. So I mentioned some of the programs that we're testing out as pilots in the 2017 to 2020 timeframe. We have incentive programs for both our residential customers as well as commercial. I talked already a little bit about the battery storage incentive for residential new construction. That's an upfront incentive that they get as part of the home purchase. and the builder. However, for our retrofit customers, for residential, we started out with a commitment to operate program. It's a one-time incentive of anywhere from $300 to $600. And the intent of that program was really to encourage the utilization of an interconnection process. We developed a standardized interconnection process for behind-the-meter battery storage. Customers are going to be optimizing for their own self-consumption from a renewable standpoint, as well as time-of-day pricing. But as I mentioned, based upon the previous slide, that's not the most optimal value proposition for the grid. So we have just launched in November our Smart Energy Optimizer program, which is allowing us to start getting some experience with regards to utility control of battery storage. So for that program, the incentive is higher. So they get an incentive from $500 to $1,000 as a one-time incentive. And then they're also paid $10 a month ongoing to allow the utility to dispatch up to 51% of the battery storage. We allow the customer to maintain at least 49% of their battery. So in the cases that they'd like to dispatch it, as well as in the sense of emergency use, the customer actually has 100% capacity of their battery for use in emergency purposes. But the intent of that program is really for us to be able to learn about how price-based dispatch signals to behind-the-meter systems will align with that customer retail benefit with grid needs. So we'll be able to start testing that out as we have battery adoption within that program. For our commercial program, we have a similar commitment to operate program like our residential customer with an incentive from anywhere from $600 to $5,000 on a one-time basis. And again, in that case, it's really about optimizing for both renewable self-consumption as well as based upon their time of day and time of use rates. But the next step will also be a data integration and basic dispatch pilot on the commercial side. We haven't seen as much battery storage adoption in our commercial customers. That's primarily because within our service territory, based upon our rates and even our demand charges, the economics are not as compelling as it is in other service territories. And so therefore, we're seeing more residential battery storage adoption because we're seeing that consumers are adopting battery storage, not necessarily for economic reasons, but for either technology reasons or backup power reasons. And then finally, I'm going to leave you with an example of one of the other pilot programs that we're running within our AB 2514 battery storage targets. Is our Storage Shares pilot program. So what our Storage Shares pilot program is that we recognize that some customers are installing battery storage just for demand charge reduction. So this is amongst commercial customers. In some cases, they're doing so because there are infrastructure constraints and battery storage can help them. In some cases, commercial customers are installing battery storage because they want that backup power. And if they're doing it because of their grid constraints or because they want backup power, we think it's great that they're putting in battery storage. However, if customers are putting in battery storage just to address the demand charge, then we wanted to have a solution for them as well. And a good example of this within our service territory is DC fast charging from third-party entities. And in that case, when you've got electric vehicle charging, you often have very peaky load, but not necessarily substantial kWh usage. And so then their demand charges are disproportionate to the amount of energy use they use. So SMUD developed this Storage Shares program. The way it works is that SMUD actually provides the demand charge reduction on their bill in exchange for customers providing an upfront investment in a battery storage system that SMUD owns, but that SMUD locates in a place that has the biggest grid impact value. So basically, it's remote from the customer location. SMUD has actually identified a location for a battery storage system on our grid where it can actually have multiple value streams, which I'll talk about. We're planning on building a 4 megawatt, 8 megawatt hour battery storage system at a location on our grid that's actually on SMUD-owned property at our Hedge facility. We have recently issued the RFP, so the RFP is out on the street today. The value streams in the specific location that we picked was first that there's an opportunity for peak load reduction. The location of this place is actually near where indoor agriculture is happening. So we've got some cannabis growers that are located in the area, and then we expect significant amounts of future demand. We also have a nearby residential community that has rooftop solar. We're going to be able to test out leveraging this battery storage for both a distribution level value as well as to sell that capacity into the market for market participation purposes from a research standpoint. So we are looking at being able to bid this into the EIM market. From a capacity standpoint, 4 megawatts is probably a little bit on the smaller side, but again, from a research standpoint, this gives us some experience to be able to see how that works. We are putting in the telemetry to be able to do so. Power generation from our organization, we actually have utility scale solar generation at our Hedge facility. So our power gen organization is going to be looking at how this battery storage could also help mitigate renewable intermittency issues. And then SMUD also has located at this site SMUD Power Academy, which is basically our training facility for not only SMUD employees, but we actually offer training classes for people outside of SMUD as well for line worker training and others. And so with the site as having physical batteries on site at Power Academy with our power generation staff doing the operations and maintenance of these batteries, it'll give an opportunity for us to not only train internal staff, but also train others on utility scale battery operations and maintenance. We've recently signed our first commercial customer to participate in our storage shares program, which is Electrify America. They are the entity that was formed out of the VW settlement. They're the ones that are putting in electric vehicle charging across the country. Sacramento is actually designated as a green city by Electrify America. So Electrify America has invested over $140 million in the Sacramento region over a multi-year period. They have put in 11 charging plazas throughout the service territory. And when they were putting in those charging plazas, they were very thoughtful and worked with our grid assets and our distribution planning staff to find where on our distribution system putting in those electric vehicle charging plazas would have the least impact or require the least amount of grid infrastructure investment. So they went through all this effort to find the best locations. But if they would put in battery storage to basically just serve as offsetting their demand charges, there's not a grid need for that battery storage. So this was really a sort of a perfect example where us providing Electrify America that demand charge reduction, but us locating the battery storage where it had multiple value streams for the utility is a win-win opportunity for both the customer and the utility. And with that, I will open it up for questions.
Great. Thank you, Rachel. All of you listening, please feel free to use the questions dialog box to type in any questions, and we will try to get through them. All right. So let's begin. Thank you for giving us a great overview of many of SMUD's programs. Let's go back to the beginning on your smart homes program. There were some questions about customer feedback and if there's been any resistance or feedback from the customers themselves on all electric homes.
I think we're finding that the developers are obviously attracted by the opportunity to not put in the gas infrastructure, so there's actually cost reductions for doing all electric, but concerns about whether there's adoption. I think because we've been making a big splash, not just for residential new construction, but also for retrofit, with high incentives, there's been a lot of visibility about SMUD's programs, both within the state and nationally, that I think the people that are buying these homes are the ones that are sustainably minded and are actually aligned to it. So I think the swath of customers that are currently buying them are excited about them, but we haven't gotten any specific direct customer feedback saying that they moved into an all-electric home and have not had a good experience. But we're really at the infancy of it from a new construction standpoint, because we just launched the program last year, and while we do have 3,000 homes under contract, we definitely don't have that many that have been actually built. But the 1,000 homes that have been done by the end of 2019, those include a majority of them are retrofits to all electric.
Great, thank you. You earlier, while talking about the Smart Homes program, you also mentioned that SMUD isn't allowed to count fuel switching as part of its carbon reduction efforts towards meeting the net zero energy goals. Have you had any other regulatory hurdles for either the Smart Home program or any of the programs you've talked about today?
Well, I think that we've been actually working really closely, and our participants in the code process. I think, you know, one thing that, for example, in the Title 24 code for 2020 that requires all new construction to have solar, one of the options under Title 24 is to leverage community solar as an option. But what's interesting is the way that Title 24 is designed is that you can do battery storage with on-site solar, but you actually can't do battery storage with community solar options, even though that's an option. So that's just an example of, I don't think it's necessarily a barrier right now, but we do believe that before 2030, it's going to be economic not only to do battery storage with PV, which is the one that we expect to come to be economic by 2023, but we think that actually battery storage alone, even without PV, could be economic within SMUD's territory before 2030. And, you know, as we think about load flexibility, battery storage is definitely one of those technologies that are perceived by customers to be less of an imposition, that they're not going to notice, they're not going to have to, you know, have their HVAC cycled, for example, by traditional demand response, that battery storage can really let them have their customer experience without having to do a lot of sacrifice. So I think that's just one example where we're still seeing some gaps. I think the other big thing that I've mentioned we're working on from a code standpoint, which again isn't a gap, but it's just a matter of, you know, when will building codes start requiring all electric homes? That's obviously something that we'd like to see, but there's a lot of regulatory considerations around that. So we're working to influence that piece.
Thank you. All right, so we've gotten a couple of questions asking for some clarifications. So Rich, I'm wondering if you could go back to the slide where you're talking about the shared value of dispatching the battery, the energy storage for both SMUD and the customer. And if you could walk through that again, specifically the question is, you mentioned that the storage and the arbitrage was good for the customer, bad for the utility, and then with the direct utility dispatch, you were able to achieve shared value for both.
Yeah, so do you want me to try to click on it, or?
Yeah, I don't know who has controls now, if it's you or Sam, but if you could go back to that slide,
Okay,
one of you.
Sorry, try now.
Okay.
There we are.
Yeah, let me click through each of the, and oops, I went too far, sorry. Okay, so so this is based upon our residential time of day rates. And so, for example, if we had designed our residential time of day rates to be most reflective of the costs it has to the utility, we would actually have a dual peak rate, right, where we'd have a morning peak and we'd have a late afternoon, early evening peak. However, from a customer simplicity standpoint, when we were designing our time of day rate, you know, that was much too complicated for customers, or the customer business unit organization said, you know, we're moving from volumetric rates to time of day rates. We really need to kind of make a transition that customers can understand. So we definitely don't want to do a dual peak time of day rate. You know, that's a little bit too complicated for the first pass for a rate design. Other things is that, you know, we designed our peak period to be 5 to 8 p.m., when in reality, from a cost standpoint, it probably should be closer to 6 to 9 p.m. But again, as we think about the customer experience and when customers are coming home and using energy, we felt that 6 to 9 p.m., 9 p.m. starts getting late, and then people were feeling like their hands were tied with regards to being able to use their energy use. So there's a little bit of compromise as we think about our rate design, right? So SMUD developed this time of day rate to have a 5 to 8 peak in the summertime, a super peak in the summertime, and then also, you know, instead of having a dual peak, one peak. So again, sort of in terms of matching the customer, matching the utility cost to the customer rate, excuse me, it's not perfect. But if you were really going to design it, or if you think about when the utility would be able to get the most value out of dispatching that battery storage, that's really that difference between the value to the customer versus the value to the utility, versus if the utility were able to purely dispatch it based upon what the true costs are to the utility. Does that explain it?
We will find out. If anyone needs further clarification, feel free to type it into the question box. Rachel, I think it's on the next slide. You talk about the payment amounts for some of these storage programs. Yes. The question is, how did you arrive at these one-time payment amounts?
Sure. So, you know, one thing that we strive to do when we were developing our incentives was that we didn't actually want to just drive adoption for adoption's sake. We looked at what the value of the battery storage capacity would be to the utility, as well as, you know, took a little bit of consideration of what customers might find as value to participate. But we didn't, I want to say we didn't want to over-incentivize, so it was just about hitting adoption numbers. And that's why you'll see the 9 megawatt goal for 2020 for AB 2514, and it not being a huge battery storage number. So it really was a balance between what's the value to SMUD, but also not trying to over-incentivize to drive market adoption of battery storage. Whereas you could say that for our building electrification incentives, we did make them very, very rich, because we were really trying to really jumpstart the market and do some significant market transformation. Since we're in this learning mode, I think we wanted to make sure that we were learning about our behind-the-meter battery storage systems before we went ahead and got to cost effectiveness, where we expect adoption to significantly increase.
Great, that's a great point. So these are your 2017 to 2023 programs, I think you mentioned, that are more pilot focused.
Right, and actually, the transition, there's that slide with sort of the different 3 years. We actually have multiple phases expected of our battery storage program. The first one was commitment to operate, which is, okay, this is just a very basic, you're only dispatching based upon your time of use rates, a basic one time. The next phase was our Smart Energy Optimizer, as I said, is allowing the utility to control 51% of the battery storage and testing out that control. Our next phase, actually following the Smart Energy Optimizer, which we expect to launch in that 2021 timeframe, in conjunction with leveraging our DERMS, which will be launching at that time, is really to start experimenting with dispatching the battery not only for local conditions and distribution level conditions, but also looking at aggregating behind-the-meter storage systems to bid in for market conditions as well. And those incentives would be even higher than that of the Smart Energy Optimizer.
Great, thanks. We've gotten a couple more questions about the smart homes and the electrification program, but before we jump back over to that, let me ask you one more storage question. You mentioned through the Storage Shares pilot program, Electrify America is the first to sign up. What are the costs to, for example, Electrify America? And yeah.
So the investment that we are asking for our Storage Shares program, whether Electrify America or for any customer, and as I mentioned, we're building a 4-megawatt battery to support the pilot program. So we're still in learning mode. This is a thoughtfully designed pilot, but we're still learning of how that works. But it's approximately the same as what a customer would be doing in terms of buying a battery energy storage system. So if you think about it, a customer would buy a battery energy storage system to get that demand charge reduction. So we're basically asking for a down payment that's a little bit slightly lower, but about the same amount that a customer would be spending for a battery storage system. But instead of just going to the installer, we're actually being able to get some different value streams as well.
Okay, so then the follow-up question to this is how many customers can you take on, and is there a break-even scenario where a customer wouldn't agree to such an agreement with SMUD?
So, and we, as I mentioned, it's a pilot program. Electrify America has contracted for a pretty substantial amount of that 4 megawatts. I think we're thinking this is targeted at commercial customers only, so it's not for residential customers because residential customers don't have a demand charge. So we're thinking we're probably going to get about 2 to 3 commercial customers to subscribe so that we can be able to do that research pilot with them. If you look at the investments in what people will be paying, it's going to be a little bit, I think it ends up being about 40% of what the utility scale battery storage is going to be. And that's why those additional value streams is what we're testing out to see of whether or not we're actually getting the full value stack to be able to make this, this pilot program fully economic.
Thank you. All right, jumping back a little bit, does SMUD have direct control of the battery, or do you work with third-party vendors and provide signals to them?
So
there was also a related question about what program you use to manage the DR portfolio.
Sure, those are all great questions. So that's been a really interesting journey, I will say, for SMUD, and it continues to be a journey. Our current demand response programs, we have a DRMS, a demand response management system by Lockheed Martin, which has now sold it to TRC. So we have the C-Load software platform to do demand response for SMUD. As we think about things like battery energy storage and managed EV charging and heat pump water heaters, so one thing that we've done, it's a requirement for the DERMS co-development, but we've been kind of sticking to our guns about is that we were looking for in the controls program, so the energy optimizer program, we were looking to work with battery storage entities that were meeting the 2030.5 Open Communication Standards requirement. So the California Public Utilities Commission has had a requirement and has had deadlines for entities to be able to meet that, and that's been a bit of a moving target. I think it was like August of last year and then February of this year, and it keeps moving. In our service territory, Tesla is the big dog in the room. They have about 70% market share in our service territory. The number 2 battery storage offerer in our service territory from a market share is SolarEdge. And SolarEdge actually did meet the 2030.5 standard back in February. So we actually chose to work with SolarEdge as the first battery storage provider for our energy optimizer program where we're doing controls. We've talked to Tesla about it, but they were looking for significantly, guaranteeing a certain amount of capacity. They also wanted a lot more for using their proprietary platform, and we really want to encourage the industry to be going to these open communication standards. So it's not precluding that we'll work with Tesla, but we started out for battery storage controls working with Solar Edge and using their platform. For heat pump water heaters, there's a 2045 standard, but a lot of the heat pump water, not all of the heat pump water heaters use that standard. And so based upon the technical requirements that we have for our program and what we wanted to have in terms of being able to leverage that as thermal energy storage, we started a research pilot with virtual peakers. So they're kind of an aggregator. And so our research pilot is currently using virtual peaker to test out the dispatch for heat pump water heaters. But as we go towards more of an integrated technologies control standpoint, we are looking at both a third-party aggregator that can help work with us with regards to dispatching multiple technologies to optimize for both the customer and the grid. So we're looking at that probably in the 2021 timeframe, as well as our considering as part of our DERMS development, what of those devices do we want to have direct control for versus what do we want to work through an aggregator to control?
Thank you. We've had a couple of questions about home retrofits and wondering if you could talk a little bit more about home retrofits for electrification in general and how likely these are given cheap natural gas. Does SMUD have any outreach or marketing strategies or targets for home retrofits?
Yeah, that's a great question. So we do have a very comprehensive home retrofit program for building electrification. So the 1,000 homes I mentioned that are electrified by 2019, the majority of those are actually retrofits. So we have very rich incentives, and I'm happy to send those out as a follow-up to anyone that might be interested for heat pump water heaters, for heat pump space heating, for induction cooktops, and then we have a bonus incentive if they do all three. We also have an additional incentive if customers need to upgrade their panel to be able to do so to accommodate electrification. Although our initial customers that have taken us up on the electrification retrofit incentives, it's only been about 2%. It's been pretty low of those that need to actually upgrade their panel. We don't know if that's because people get the estimate and then they don't want to upgrade their panel, so they don't do the retrofit, or if in general it's just the early adopters that are doing it and therefore they haven't needed the panel upgrade. We do have a very extensive customer outreach planned. As I mentioned, we've been working with our marketing team, and we do have a very comprehensive marketing strategy that we'll be launching at the beginning of the year. We have TV advertisements that are coming out in March. They're actually pretty significantly different than the traditional TV advertising we've done in the past on energy efficiency. So our marketing team was, you know, a little apprehensive at first, but now really excited about kind of moving our customer towards that. I think that there's going to be a lot of education needed. You know, we have a lot of tools, as I'm sure a lot of utilities do, on helping customers, educate them about their energy use, what are those end uses, and you know, as we have started down the path of time of use, we're starting to educate customers about how to think about their energy use, about when. But a lot of the education for decades has been about use less and energy efficiency. So that's a transition, I think, for customers to think about how do they leverage these technologies about when to use, and it's not always use less. It might actually be used more at certain times. So as we think about, you know, workplace EV charging, and in California, where we've started seeing curtailment of solar generation in the late spring, in the spring when you've got a lot of solar generation, but the HVAC load hasn't kind of come online. When you've got curtailment or you've got negative pricing in the markets, that's a great opportunity to charge your EV, to heat up your heat pump water heater, to do those types of things, to charge up your battery storage when not only the power is cheap, but also you're charging it up with renewable energy. So those are things that, from a customer education standpoint, we do believe that there's a lot of work to be done. And so the marketing campaigns are a start, but we've got our Energy and Technology Center, which is an education institution or a group within our organization that teaches classes about lighting, about energy efficiency, about different technologies. And as mentioned, we've started doing induction cooktop education classes and things like that, just to get customers familiar with the technologies.
Thank you. Well, I realize we're at the top of the hour, and Rachel, I want to thank you for packing so much information into an hour, and I really look forward to hearing about the results of all these pilots and the data that comes out of this. A lot of you have submitted questions on how you can access the slides. So if you have signed up for this webinar, you will be receiving an email with a link in the next day or two so you can access the slides and the recording. So thanks to everyone for joining. Sorry we didn't get to all the questions. There were lots of great questions. Thanks for submitting them. Thanks for being here and for participating. If you, CESA often has webinars, and here's on the slide that's up now are some upcoming webinars. You can visit our website to see the registration links. Thanks again and have a great day.